Should I do?
Also, we turned on the overhead mic,
Is that good enough?
and I think this is good to go. Good to
Oh,
go?
we don't need a microphone. It will
There you
get to
go.
the internet by magic.
Miracles, okay.
We're all set.
Great, fantastic. Okay, so the one thing I didn't mention about Peter Williams, who is our new CFA AAS Innovation Scientist, thank you, Peter, is that also the Seamless Astronomy Program, which is the sponsor of this series of occasional colloquia, will come also under Peter's purview. And so I'm going to do this introduction not in place of Peter, but because Arzu is my close friend and collaborator, and even accidentally, I didn't know, put my name on her slide. So Arzu Çöltekin here is a card-carrying visualization expert, and she is not an astronomer. She was trained in engineering and geographic information science. She went to undergraduate, she got her PhD in Finland, and then she's been in Switzerland on the faculty of the University of Zurich for quite some time, and she's moving, but I'll let her tell you about that if she chooses to. And anyway, so I've learned so much from her about the way that the visualization literature can be translated into actual practice rather than to more visualization papers. And so today what she's going to do is tell the rest of us a little bit of what I've got today from Arzu. So thank you for coming, Arzu.
Thank you, Alyssa. Here. As I mentioned that I'm changing jobs, I'm moving to computer science department still in a Swiss school. The details later. That will be in February. So far I've been embedded in a geography group, but this project is a very interdisciplinary one. And I put Alyssa's name because it's actually our joint project. This one is something that we came up together. The examples that I'm giving through the talk are from my work and my team, and I'm going to give you a quick introduction to my interests before I move on. But the questions are essentially actually almost more her work than mine, and the blog too. So that's why your name has to be there, whether you approve it or not. All right. So we will talk about these, and these are not meant for visualization experts. I don't know how many are visualization experts in the audience, but these are meant for people who are actually producing visualizations as a byproduct of their work. So a lot of us create them, right? We create plots and maps because we end up needing to do it because it's actually quite useful. So we try to convince people why they should care about these and what they can do to some degree. That said, my interests are sometimes in the nitty-gritty of the visualization and what you can show. These are a couple of my projects I drew by hand recently. So I work on how shadows or shading can allow us to perceive 3D shapes, and sometimes that causes illusions. I won't be showing examples of that today except for one slide. I work on color and how one can use color in visualization and whether we can discriminate colors in a way that we can quantify the discriminability of colors. So if you can put a number on the color difference and then be able to have a threshold and say any difference less than that, people cannot tell this green from that green. That kind of work. And then there's a little bit more on that, but roughly speaking. And the third project I featured here is about realism, and there's a little bit of an example on that. Realism abstraction is always a little bit, it's a very, very strong theme in my research because I studied in my PhD something called photogrammetry. It's a lot to do with computer vision, specifically dealing with geographic data, and it started with the aerial photography, and there was a lot of photography and photorealism and virtual reality. And my minor was cartography, which is a lot to do with abstraction. So how do we abstract and generalize and show the relevant information? And there's tension between these two. One is trying to replicate realism as it is, to simulate and document, and the other is trying to summarize it for you so that you don't need to deal with the information that is not relevant at that moment. And to decide what level of realism and abstraction is necessary at what moment is actually an entire research agenda. The other project is about measuring visual complexity directly. There are certain algorithms that are informed from visual literature where you can say, here I feed the algorithm a screenshot of my plot, and the algorithm tells you a score. and that score is supposed to tell you whether the visualization is very complex or very cluttered, or if there are many salient objects in the visualization. And in this project, we try to see what the algorithm tells you and how human performs with that visualization. Do they match? Sometimes we have direct human ranking, and that matches quite well, but sometimes we give them actual task and see whether they can, let's say, learn a route or remember what they have studied, and then it gets a little bit more complicated. And then I study interfaces, I study whether three-dimensional visualization is better than 2D, and I study vision-inspired paradigms to do level of detail management, and that's the last project right there. And in here we do, this is called geofoveation. We take geographic visualizations, they come in large bulks, a lot of imagery, and we try to understand whether we have to show the detail at every spot, given that we know where somebody looks. So if I look here, I don't see a lot of detail in the periphery, or similarly in the 3D, there's a focal spot and you don't see a lot of detail or color. So we try to do this in real time. We capture person's gaze because we have eye movement devices, and then we discard detail in the periphery and in the three-dimensional space. This is trying to keep the visual field modeled and do the visualization sort of with fidelity with the visual, what's happening in the visual field. Of course, all these projects are done with other people. This is the people that I have worked with. A lot of the examples you'll see are done by them. I mention them by name later, but I also thought that it's fair to show their faces first. All right, so this is the project, and there's a blog about the project. So if you are curious and if you haven't discovered yet, we have a kind of a framework, if you like, and this is going to be a collaborative blog. This is quite recently launched. I wanted to say launched, it's a joke between us based on my mispronunciations. Right, so if you're interested in a lot, like there's a little bit more information on this site, 10qviz.org. I will try to go through these questions now. I will not be able to cover all of them because we would be here forever. So I'll skip some of them with very brief statements, but I will expand in some of them. And I will begin by saying why we talk about visualizations at all. This is probably familiar to some of you in the room. And it's actually a very good demonstration of why visualization is so powerful. You see what's changing if you look at the numbers. If you only looked at the numbers, you would not know any of these patterns, right? So if you look at the numbers here and don't pay attention to the little part we usually, anyway, round it down or up, you would think that these numbers show exactly the same thing, but it's really not true, is it? So you can actually have a number of different patterns that are expressed by different numbers. Therefore, looking at a plot, in fact, ideally, looking at multiple plots of your data is very revealing sometimes that the data cannot express by itself. And this is another one, so you might have heard that pie charts are not very good if you have been in InfoVis conferences. If you have never been to InfoVis conferences, you probably don't know that people have a problem with pie charts. But they're like, pie charts are not good, don't touch the pie charts. And here's a demonstration why pie charts are not good. It's not necessarily a blanket statement. There are things that pie charts are good for. But in this case, there's 5 values somebody is trying to show, and to me these all look the same, to be honest. If you show the same thing in bar charts, you see the differences in magnitude, and it becomes rather obvious. And this trends, I mean, I could never tell here. Like, honestly, perceptually, it's very difficult to tell the differences in magnitude when you use pie chart. With the bar charts, that's very clear. So the pie chart works well if you're trying to show, let's say, 2 values, and it is the proportion of a whole, so you have 100% and you want to show that this is 20%, people are doing fine with that. But if you are trying to show magnitude differences, go for bar charts if you can choose, for example. Another thing, this is the opposite direction. So I let you study this a little bit and see what's wrong with it. This is the number of professors in our school, and this is from our actual webpage. So Can somebody point it? What's wrong with somebody?
The
Right.
scale.
So I don't know if this comes from like a desire of like, oh no, it's so embarrassing the number of them and we must do something about it, or if it is simply like, oh, like this just we don't see enough, so let's just mess with it. But the scale is just, it makes it impossible to compare, and this it could be like in this case it can be pretty harmless. This was 2015. I didn't check if they updated. I thought they might have had some reactions, but this is sort of quite important, right? If somebody doesn't pay enough attention to look at these, you might think that it's just about the same. And perceptually, that's what you do with data journalism, with election results, with this kind of communication of social subjects. You will see that people kind of manipulate you just a tiny bit because that serves their message, that serves their agenda. These are very simple things. And one would think once you are told about them or once you think about them, you think that this is, how can one not think about it? But there's a lot of this out there. So if you start looking at it critically and look through the scientific publications or journalistic pieces, you will see more and more and more of these. It's quite interesting. So where does this come from? Is that partly obviously there's an agenda and people would like to perhaps manipulate what we perceive, but also sometimes people don't understand the impact of it. And that's the part I call literacy. It's about reflecting. Literacy, somebody recently had a very critical blog post and said, literacy suggests kind of binary, like you know how to read or you don't know how to read, and this is also implies that some people are illiterate, and maybe this is not the right word, but I kind of conceptualize it rather as a spectrum, so we understand things, but we can get better at something. And in this case, we're not only talking about like makers and readers, because we are both makers and readers. There are only a handful of people whose job is really to prepare visualizations. A lot of the people are dealing with data, and visualization is just happens as a byproduct of their work. And it is important to try to develop ourselves a little bit, because we do make inferences for opinions or take decisions and actions based on visual information. It is a more digestible form of information. We are highly visual beings. In fact, some say, and these are textbooks, it's not just hearsay, that about 40% of the brain processes visual input. So it's a lot of our cognitive resources that processes visual input. We are wired to interpret visual stuff, so we are extremely visual beings. Not to say that audio is less important or smells, you actually get a lot of information from that, but nonetheless, we need to study this. So one framework I have, and I think about visuospatial displays, is this one, and this is kind of on a three-dimensional space. You have human factors on the one hand, so who is the audience, what are their perceptual and cognitive, and this is I now put this link here because this is actually a spectrum rather than a binary, so the perception and cognition is not really so separable, they affect each other. So what are their capabilities in terms of this? So you have expertise, and I'm going to show you some evidence on that. You can have color blindness, you can have age that affects certain perceptual abilities, you can have spatial abilities because you have played many video games, and so on and so forth. There's a number of differences among people depending on their background and sometimes based on their physical and chemical, psychophysical differences. And then there's technology and design factors, and I'm kind of in this corner. I try to learn about the context in which the visualization is shown and who the people are, and I do experiments and I try to feed it here because I feel that I can manipulate this more easily than changing the context in which people need the visualization, or in fact it's harder to train humans, and I'm not in the psychology corner. So I try to learn about visualizations and I see if it works for you guys as a group. Let's say if I take a bunch of astronomers and that works very well for you, and then I take a bunch of computer scientists and they might have different needs, right? So this would be the kind of thing that you would do, and then in the context we will also have a look at some examples how that matters. Then you can come back and say, well, for this audience and for this context, maybe I need a different color scheme, something like that. So this would be the three things that actually keep interacting. I won't spend a lot more time. I will actually even skip the high-level, low-level explanation for now. Happy if you approach me later, so that we can actually keep this more or less in time. So now I'm starting with the questions we came up with. The first question, and I thought, and we believe this is one of the very important questions, is who the audience is. And expertise is especially emphasized here because we talk about scientific visualizations a little bit. And the scientists, when they prepare visualizations, they tend to test it on themselves. And it's like, oh, if it works for me and I understand that and my friend understands that, I think we are good. And then it goes out there and the people out there are not you or your friends because they don't have the same level of experience. So in that, expertise does matter, but also age matters. Gender can matter. I will show you a confidence-related example. Spatial abilities is a thing. It's actually a quantifiable, measurable thing. It's malleable, so it can change by practice, but there are differences in spatial abilities, and very simple tests can actually predict your ability in map reading and so on and so forth. There's actually a fascinating area of study. Here's one evidence that, as I promised in the title, that expertise matter. Here, a number of people are reading a soil map. Soil maps are super complicated because there's a lot of categories. Soils are what they are. You cannot reduce the number of categories. So we tend to have these extremely colorful maps. So there's like 20 or more categories and somebody has to make sense of it. It's pretty hard. So in this study we changed the legend. It was a very simple, very subtle manipulation. We alphabetically ordered the colors or we perceptually ordered the colors, and we asked a number of people to try to match the colors in the map with the colors in the legend, so they are supposed to identify categories. And you see this is quite fascinating how it particularly goes. So with people with no expertise, partial expertise, and high expertise, and with no expertise, with partial expertise, with the ability to interpret soil map going high, accuracy goes high. So people with less expertise are not doing very well. Partial expertise, they do very well. When it comes to high expertise, they do with the alphabetically ordered, they do really well, but not with the color ordered. And this is the convention. In this case, expertise interferes because they are used to reading the legend with an alphabetically ordered color scheme. And the others, they are actually the people who are not actually very high expert, they are not affected by this as much. And the response time confirms the exact same pattern. This is another one. We have grouped people, and the study behind this is that you have two different atlas interfaces, and they are supposed to find crime rates in different towns. They are supposed to go through certain interface elements and so on and so forth. And this is now grouped by speed, so how fast people have done and how slow people have done, and then have done the tasks. And the slow group, you can see there's a lot more variation, and fast group is actually doing very well. And here, not surprisingly, majority are experts. And they were two different designs, and here we infer that we have more analysis that I'm not showing you, that the experts could bypass bad design. Here, they knew what to expect, and they could work around an interface that was actually design-wise not very helpful. But the novices, they were completely guided by the design, and when the design didn't help them, they really, really failed, but the experts were able to kind of push around or work around and quickly get around it. And to show you one, and this is actually from that study, so here is somebody's eye movements. So what you are looking at is the Atlas interface. Somebody is supposed to look at Maine and tell us what the crime rates are. And this person takes about 11 seconds. And these little nodes show eye movements, and the size of each one is the length of fixation, so how long they were looking at this place, and the numbers show the order. So somebody is finding the place for some, they usually start somewhere in the middle. That is not meaningful, but they look for the place, they find the number, 11 seconds, and I have my answer. Now, the second person doing the same task. And you might realize it's an interactive map. They are not even in the right coast anymore. So they frantically look for it. It takes 521 seconds, and eventually they give up on the task. Now, you might think that this is perhaps a hard task, or maybe this person is not maybe they didn't sleep well the night before. There may be a different explanation. We ask all kinds of questions to try to understand. But I try to use this, and this is the worst and best in this particular experiment. I try to tell people, especially my students with this example, that this is exactly why you can't test your designs on yourself. This is probably you. And this is probably one of your clients. And therefore you must at least attempt understanding what like walk in their shoes a little bit, or try to understand what it could be that they actually understand or do not understand. It's another factor, another individual difference, age. In this case it's aging. You could also have developmental studies. So children are another story. That's also a special group. There's different age groups where they can do well. And in this case, we are looking at people between 20 and 30-year-olds and 65 and 75-year-olds. And the task is route learning. And they are trying to use 3 different display types. And you have a bit of abstraction and realism going on here. And here you have the full realistic display. This mimics, it's a fictitious city. We have, yes. So we have created, and then photo texture, so it should be unfamiliar to all. That's important, so that they don't do well just because they know the place. And then here is selectively photo textured. We have been basically highlighting important elements. So if your goal is to learn a route, apparently you pay attention at the intersections and in the direction of turn. So what we did was we highlighted those buildings with photo textures. And photo textures, that was like you could highlight with anything, but we did it with photo textures because we wanted to test the virtual reality for route learning as a training device. And if you learn, if the goal is to learn your route, hopefully this transfers better to the real world because the building should look like that eventually. And then you have a baseline condition where you have 0 photo textures, and we told them, and they were seeing videos, we told them that somebody drives you from A to B, try to pay attention to this path, you are in the passenger seat, and you're going to drive this route on your own later. So they try to learn, it's not incidental, it's intentional learning. And what you see is that right after they have done the experiment, this is the performance of the younger people. The green ones are from this condition where we designed quite intentionally, and the yellow ones are from the baseline abstract condition, and the other sort of jade color is from the realistic condition. And here you have the younger people right after the experiment, older people right after the experiment. So we have an immediate recall condition, and we have a delayed recall condition, and that's quite mean. We call them back 1 week later and ask them, what do you remember after they have seen like this 10-second video, and 6 of them too. It's like, did you see this? Did you not see this? They were supposed to also sketch the route that, like, it's, I thought they weren't going to do well at all, but you see, it's not too bad. Like you see with this condition especially, 70% of the young people actually are doing, or 70% of the time, young people are doing quite well, and about 56% the older people are doing fine. And that's 1 week later. And we think that this is kind of learning, and this is memory. So you kind of like remember now, like after this talk, maybe you remember a couple of points that I made, and 1 week later, if it's still resonating with you, maybe it's learning, maybe something that mattered. So this is just to show that age matters. So you have, also obviously visualization design matters, it shows more than one thing, but we have a considerable difference between older and younger people. I also wanted to show you this is quite interesting. Aging apparently does something mean to us. We've become more confident, especially with memory-related stuff. This shows confidence. So older people are overconfident. This side of the graph is confident, this side is underconfident. And this condition apparently also compensates or calibrates for confidence. So closer to 0 is good, and 005, 006 is quite good actually in comparison. And overconfidence, especially if the idea is that you try to learn your route, and then you get out there and try to find your way, and you think that, okay, now I got it, then you didn't really get it because you think that you get it. It's a little bit threatening, so we thought that this is actually also interesting to try to correct for that. So the key message, however, is that there's individual and group differences, and as we age, it happens, and this is what happens. On the one hand, this graph is entertaining, on the other hand, it's depressing. So around your 20s, it starts going down. Short-term memory, working memory, long-term memory, speed of processing. One good news, this is experience-based verbal knowledge. So I tell students to listen to their supervisors. They do know stuff. So there's much more about this, but since, Alyssa is looking at the watch, I am actually not tracking my time. Tell me when I need to speed up. All right.
25 minutes.
All right, 25 minutes, I can do it. Very good. So this is another thing. So now I said that the expertise matters and age matters, right? So this is the other thing. And I'm showing this to you both as an example of how shadows can impact your perception and how confidence, gender differences will matter in terms of confidence. So I ask people, if you see this thing, the line, if you follow this one, do you see that on a ridge? How many of you see that to be a ridge? Well, a bit more than half. Okay, so if we switch that and see this one, how many of you see this on as a ridge?
No, it's a valley.
Maybe one or two. Okay, so there's something perceptually strange going on here, right? So this is to do with the direction of light, and that's actually a satellite image, and this happens in the northern hemisphere a lot. So your mind assumes the light comes from above, and the shadows must be below. And the way that the satellites collect images, they are sun synchronous, so they go around 10 a.m. and then the sun's position and the earth is tilted. The shadows are in the northern slopes. And then what we do is that we show the maps north up. And then your mind goes, oh, shadow is on the north, that must be south, let me correct that for you. Because usually it's supposed to be below, and you have this up and down relationship. So with this one, we have done a number of studies because in geographic information visualization, one way to show terrain is shading. We actually use this quite consciously. And then first to understand the prevalence of the thing, how many people actually agree on the illusion, and some people can bypass this illusion because they infer that this is a river. And rivers don't flow on a ridge. So, or then there's snow sometimes, depending on the season. So we asked them, and then they could tell us that this is clearly a valley, or it's a valley, or I'm unsure, it's a ridge, or clearly a ridge. Now you see, people with no experience and some experience have similar results, accuracy results, whether they are women or men. And when we come to confidence, for women, whether they are experts or non-experts, their confidence levels are similar. For men, the less experienced they are, the more confident they are. And I was like, what is going on here? How do we socialize boys? I don't know. So this is a bunch of things that is, but the confidence literature is abound with this. There's a thing about, people usually frame that as women being underconfident, but I don't know if it is true that the women are underconfident or if it's men that are overconfident. Then we can open a whole can of worms there. All right, so what I'm trying to say is that if you're thinking about visuospatial displays, it is possible that your audience, people that you interact with, as you show them and prepare them and present them things, might have different attitudes, different levels of comprehension, and different limitations. So in some way or another, it is important to know that so you can actually try to optimize, right? So the other questions I want to expand as much. So explore, explain, I have basically one line. It's one of the questions of what the goal of the visualization is. So if the idea is explanation, and that's what many people perceive visualizations to be, they think that it's a communication tool. So you know something and you try to present what you know. But that's not usually what we do these days, right? This is not the only thing we do with visualizations. In fact, especially in science, we use visualizations as a tool, as a process, not as a product, as a tool to actually investigate the subject matter. So it's usually interactive, and you look at the data multiple ways, and you might not even print that out or publish anywhere. It's you who's looking at it to make sense of what's going on. That's what the visual analytics tell you. So that would change something too. So if your goal is not to communicate with the visualization, so now I've discovered something, and let me try to tell other people with the visualization what I'm trying to explain, but I'm using it for me to understand something. And I sit in my computer and I try to look at the data from multiple different aspects and select and show and compare. So that would be the exploration, and obviously the design considerations are completely different in this case. And then we thought maybe an important thing to ask is whether you want to show or explore in an exploratory scenario pre-existing known human interpretable categories. And this is kind of important because certain visual variables will occlude or help distinguish categories. And a good example of that is a use of the color. And this is a very famous example. Some of you in the room might know this one. This is from 1996. So you see this is exactly the same data, just different color scale. And you're looking at elevation categories, and the legends as it shows here, it goes below 0 or above 0. And if you look at this, you can see, for example, some stuff is lost here. I'm able to see the coastline and actually elevation below 0 much better with this color scale. And here it gets quite confusing because it's not that clear what is below 0 and what is above 0. And sometimes you might have also heard that rainbow colors are not good, and why are rainbow colors are not good, or continuous color scales in general are not really ideal. This is where it comes from. Sometimes it's very difficult to distinguish categories in this particular case. One success of this is also because we have a perceptual association, or maybe it's a learned thing, but we associate darker with more. When the sea is deeper, it will look darker, right? So this is the kind of thing. So it exploits a little bit of what you know, and here you don't have that necessarily because there are still bright colors in the areas where things are actually higher or lower. So I thought I had another example on that, but maybe I skipped it or I put it at the end. It doesn't matter. So patterns, this is very related to the categories in some way. But here we thought that the main idea is sort of more in the exploratory direction when you have unknown things that you want to explore. So in the other one, we thought that it's more about categorizing what you already know. You have documentation and then you created categories and now you want to show them. And here, you don't necessarily know what patterns are in the data. You start without knowing them and then you actually try to explore. And the example for that, and I'm not going to elaborate for that too long, is the Rubis, for example, with the multiple link views. So you can actually try to, so here you start with an unknown data set. You receive a bunch of observations and then you want to understand actually if there is a pattern or an anomaly in the data. And here, this is a software, for those of you who haven't heard it yet. It's Alyssa's brainchild and her team. They are developing this. It's a multiple view software that you can actually put imagery and all kinds of different plots, and they are linked with each other, and you have little selection here. It will be also reflected on the other views, and there's a number of things that you can do, which then allows you to observe patterns and anomalies, if you like, in your data. And for that kind of, we think that if this is the goal, the multiple link views and interactive displays are quite important. So the predictions and uncertainty is another category we thought was interesting to discuss, because if you are working with data, one of the very commonly executed tasks is that you model that and you come up with predictions. And as soon as you do that, and as in many statistical operations you have a level of uncertainty and you want to mark this one way or another. So some colleagues argued that maybe visual analytics is the solution. A perspective on visual analytics is better than visualization for this. And visual analytics basically is supposed to combine both computational and human abilities. So you would have a suite in which you can do statistics and you have visualizations together. The visualization can be interactive, but it's usually more on the display side. For the first people like me who study all sorts of semiotics and visual variables and all sorts of ways to design visualization, I thought this is an interesting example that could actually be linked to uncertainty. So it's another realism study actually. So we have been showing people 3 different levels of realism, again, a different kind of setup. And the question was, how certain are you that above display shows the exact location of the buildings? This way of showing has nothing to do with whether buildings are in the right location or not. But you see that people think that if the visualization is sharper and closer to realism, the better the accuracy of the data should be. So it really goes down step by step down here. And here you have basically a little bit photo textures, here you don't have, and here you have sketchy edges. And that sketchy representation and blur and similar ideas have been explored in visualization literature as good candidates for communicating uncertainty. So if you have to draw something like a map or some sort of visual, obviously in a bar chart you usually do an error bar or something in that lane, in that direction. But in this particular case, if you really have to have some sort of visual output, maybe this sort of intuitively seems like there's something uncertain about what you're showing. So there are some literature in this area as well. Right, so when it comes to dimensions, this is one other question we think that comes up very often, not only because of the spatial dimensions. Obviously, a lot of the physical objects are three-dimensional, but we measure and observe a lot more about these objects, both in geographic information science and astronomy and other areas. So one object that could have a single spatial location could have many, many, many values and attributes around this particular location. Now, how do you handle that, and what do you need to do? I'll give you two examples based on spatial dimension because it's the first reduction. So you reduce three-dimensional data usually into two-dimensional space. Some of you might be familiar with that. So you have here a bunch of medical doctors, a bunch of heart surgeons. In fact, the studies by Michelle Borkin, those of you who might know her. And it's an influential paper in the sense that this seems to be has high fidelity. You know what you're looking at. But if you had to diagnose what is wrong with this, or if there's an anomaly in this, putting that into a two-dimensional graph, and actually they also played with the color scale. I don't show you the whole study. Welcome to go check the paper. It really increased the number of correct diagnoses. So changing. So here you have to. The problem with this one is that you need to remember what was behind, right? It's not in front of you. So you have to judge the pattern from the memory. So something you see, and then you see it from the other way around. And what you have seen, you have to remember, and now compare to what was in front of you. And here, everything is laid in front of you, so you have a bit more time to actually go back and forth and compare. So when they went from 3D to 2D, I think the original numbers were around 30%. When they went from 3D to 2D, it doubled the number of correct diagnoses that doubled, something like 60%. And when they modified the color scale, it went up to 90%. So you don't want your surgeon not to detect the heart problem because you have done the wrong visualization, right? So this is kind of shocking, and it's a very impressive example of the small, subtle things that you should do so that your audience actually picks up what they need to pick up. In a very similar way, one of my students did this, and this is a climate change study. Somebody has been drilling holes in a Swiss mountain and tried to observe temperature changes under the ground. So he thought that if you show it like this, which is the software default, by the way, it's the rainbow colors and two-dimensional output, he thought that maybe 3D is better for that because here you don't know what you're looking at. I mean, you might recognize the mountain shape, perhaps, if you are super familiar with that particular mountain, and in Switzerland people might. But the thing is, here it could be basically anything, and here you know immediately that it is inside a mountain what's happening, and he thought that matters. And in fact, for identifying the gist, so what the object you're looking at is, realism is good. You can name it very quickly, you can very quickly tell. But then he gave people tasks in which he was like, okay, tell me what the temperature is 20 centimeters under here, and he put a little scale here, and 25 centimeters under here, or meters under here, etc. And there, this is terrible. This is not doing very well. And in his other condition, he actually introduced lines between categories. And that helped a lot. I'm not showing the whole study just to spare the time. Basically, what I'm trying to say is that in this particular case, if we consider dimensions, number of errors was absolutely more with three-dimensional display. People made more mistakes because there is some irrelevant information and it increases the cognitive load. That's our interpretation of it. And it took longer for them to in fact come up with the same information or say less accurate information. Took even longer time to come up with. Yeah, right, so this wasn't helpful either. That's the sort of the side effect, and the other color scale worked much better. Now that I kind of said, three-dimensional visualization isn't very good, here's one example where it worked well. So it's like this, then it depends on the context and what the task is. So in this particular case, somebody's reading a time plot, or a number of people are reading. These are eye movements again, and there's a number of people's eye movements overplotted. And if you look at the two-dimensional plot, you think that everybody is just following the same sequence and it's an absolutely similar pattern, I don't have to worry about it. And if you take these eye movements and put it in a three-dimensional graph, then you have the map here, two-dimensional map, and you have the time here. This is called a space-time cube. And then you see this one person, and if you study this one person that actually doesn't behave like the rest, you see that they read the graph the other way around. And I don't know what the reasons were, but it's interesting. So you now detected an anomaly because you looked at your data in more than one way. And yes, maybe 3D would be terrible. And in fact, both of these are terrible for trying to, because there's a lot of overplotting. You would probably go for some sort of density visualization in this particular case. And then if you needed individual ones, you could call them. But here, the main message that I want to give is that really, if you are able to afford it, plot your data in more than one way. Because maybe one way reveals something and the other one reveals something else. So this is kind of the message. And of course, when you say 3D, 3D is not one thing, there's all kinds of 3D. And this is one classification, and I have once thought about this from abstraction to realism and non-immersive to immersive, so there's all kinds of 3D. And this, what I'm trying to say by showing this one is that when we talk about visualizations, we tend to have our own image of something. When you hear a word, you think of a particular corner of it that is more familiar to you. But almost every term you hear has something like this under. There's a large number of options, and in fact you can classify and categorize them based on a number of different criteria. In this case, I use the immersion and abstraction and realism, but you could also have different criteria, and you would end up actually having a whole taxonomy of different kinds of visualizations. And this kind of leads to the display types later, or links to the display types later. Okay, abstraction accuracy. I'm going to show you a few examples of that as well. Already exhausted? We're doing fine? Good. So here the question is whether you need to show all the data, and is summary or abstraction is okay to do. And this is an important question to reflect, because trying to show everything at once can backfire, as we have seen. But also summarizing, that's a sort of a tension between them. As I said before, summarizing is also a bit of a problem, because what if you exclude something that mattered? Right? So this is again, it speaks for interactive displays, perhaps, where people can call and experiment and look at it themselves, but you can't afford that all the time. So it's like a decision to make. For realism, as I have shown sort of briefly earlier, there's this concept called naive realism, so people would like to show as much data as possible, as with high fidelity as possible, and people do prefer that. People like realism, and in this one age study that we talked about before they started the experiment, we asked them which one of the three you think you would prefer if you were trying to learn your route. And 88% of the younger people thought that the realistic one is best, they would prefer that, and 97% of the older people thought that this was good. And only 12% of the younger people thought this was fine, nobody wanted this one. That's like this poor thing. And then there's this 3% here that also thought, maybe I could live with this one. And then after the experiment, and you have seen how well they did, right? So like they all clearly do better with this one. Older or younger, now or later, but they all clearly do better with this one. when the task is memory, yeah, it's not about recognition. That would be perhaps better here, I don't know. So after the experiment, a lot of the young people shifted their preference now to the tool that worked better for them, but not necessarily. The majority of the older people still wanted to stay with this one. And this is kind of a shown phenomenon before the study from Smallman and John. He has a number of papers on this one. It's to do with sort of like being able to assess your own performance. Is to do with it's like a metacognition thing. So it's like if you are aware of your own performance, then you are able to switch. But I think that there's a like a bit of a complication there to really say that people do not understand how well they did, because I think they sometimes do, and they still might prefer the other one. Because I often think of that if I'm shopping, sometimes something is not exactly comfortable, but I like the look of it and I'll still do it. Right? So sometimes preference is a little different thing than actually knowing what is good for you. Would explain all the high options. Why would you do that? But okay, we do that. Right, so something like that. We don't see that in confidence so much, but with preference we see that. All right, so it's another example of very much like an obvious abstraction and realism example. So you have photorealistic maps and you have abstract maps. These are from satellite images. You can use them as maps. I don't know how many of you actually switch to satellite when you are using Google, but we asked them for visual search, route planning, and compared how well people do with the two of them. Both visual search and route planning tasks longer with the satellite image, and people with higher spatial memory capacity, they did better with both of the tasks, and that was a bit of they did better with the satellite images as well. In another one, we asked them whether they would, that was an animation, they watched an animation of this red dot flying through this route, and then we asked them, do you remember it in another animation after this was done, is that the route you have seen? So it was kind of, I guess, a binary answer that they could give. And they did this with maps and with the satellite images. And here you see people did a little, like, tiny little bit better with the satellite, with the road map, but consistently so. That's statistically significant. Response time didn't matter, but the confidence-wise, they were able to detect that they were doing better with the road map. So they also are more confident with the abstract map in this particular case. This was independent of the spatial abilities in this case. In this particular study, high spatial participants were especially good with the abstract maps, and we measured their spatial abilities in a number of ways. And we actually measured anxiety, which is very interesting too. There was a neuroscience group in Lausanne. They actually took saliva samples and they looked at cortisol levels and everything that's crazy like this. So you have sort of a nuanced finding that people with lower spatial abilities and high anxiety traits, they were doing especially bad. And that, for me, it's like, oh, so far I have been like, oh, spatial abilities, but I guess there's like, it adds one more measurement in your experiments to see that really, you know, that's maybe not only about the spatial ability, but about how anxious you are. And there's also this, like, as you go in deeper and deeper, there's a lot of things in there. You have trait anxiety and you have state anxiety. So there's different levels of anxiety based on your personality, but we all get anxious in certain situations, and that's the state anxiety. So you must measure that depending on, like, there's trait anxiety scales, there's ways to measure that, and then there's state anxiety, that was the SWOT. All right. So context and scale, there I'm going to keep it fairly short, but I guess you can just remember this. So context and scale in this particular case. So that matters. And then with the metadata, as you all know, it's very, very important whether you think that it is meant for your colleagues who should know or it's meant for others. It's very, very important to display this so that it really gives the framework of what the visualization is about. So there's, we must make this available, captions, labels, interactive elements. So that's basically kind of a key for legibility and sense making. The display types, that's a whole agenda, so I'm not going to take longer. So you just remember that one. So you have, just for 3D you have all these, but you would have this type of taxonomy for color and animation and static, and oh my god, that just doesn't end. So there's a whole bunch of PhD theses to be done, waiting to be done there. All right, so I'm going to wrap it up. So what should we do now that you have like a superficial introduction and some evidence-based answers? If you are interested in the subject, and I assume that you're not only here for the Dunkin' Donuts coffee, so please join us, have a look at this thankyouviz.org. Tell us whether you would have different questions than these 10 questions. If you have different questions, we are very happy to entertain the idea, or if you tell us that, you know what, these two categories could be merged and these other very key questions should be in there, we are happy to hear from you and consider that. And then if you have questions and you are like, okay, I've checked this 10 questions, but something is not clear to me, can you make it clearer, can you give more examples? We are very happy to do that too. And if you have examples that fits very well to one of the 10 questions that you heard, provide us with them and we will include them in the blog. And if you have even more interest in that, we want to do guest posts. So if you are like, oh, actually, you know what, I have a whole story to tell about my own visualization experience and it fits perfectly under the abstraction and accuracy scale part, please give us a nudge and we will be happy to invite you as a guest speaker. So thank you, and I leave you with this from actually Alyssa's tweets.
So we have to give you a minute to let it sink in. Sorry to hear. So I know we started a little late because of the technical issue. Sorry about that. So if anybody has to leave, we won't take it personally. But otherwise, we have time for some questions. Yes.
Very interesting, thank you. Creating informative, nice-looking, immediate plots is a tough job. So that's something, the visualization of plots. So applied science practitioners, where should we get that kind of knowledge? Because it's a kind of difficult thing to get.
Yes. Right, so that is something that I think the visualization community is trying to, they are realizing. So sort of, it's very easy to go into a room and talk to other people who are really obsessed with visualizations, and then if you wanted to translate that knowledge, and there's a couple of efforts, but there's not a really unique, comprehensive resource yet. That's why we started this, and we hope that this one becomes so. So this is like the 10 questions are basically just a framework, and hopefully it will unfold all the practicable rules of thumb for the visualization.
Click on one to show what's there. Maybe click on one to show what's
Sure.
there.
For example, if you click on one of them, you can see here, I showed you all these individual differences, and here you see an example of two different kinds of visual outputs. One is meant for press, and the other is meant for a scholarly article. And if you are in here, you can actually hover over the image and get a little bit of educational note why this is done. And then if you have, here's okay, the information in the color bar about the color of the host star is meaningful to experts, but is removed at the left since it's not as important as the other information.
So we seeded each question with one kind of work example like that, and what the blog is supposed to be for is to collect more examples, and then each one has, can you show the search thing, Arzu? At the top.
Was it here?
So we'll go to successes, just do that. That's fine. So we have some examples. You see the categories on the side, and so if you're interested in particular categories, you can check them off, and then you can find examples that kind of touch all those categories. So it's not like each example matches exactly with only one question. It just sort of highlights that question. Yeah. And so, I teach visualization here, right? And so I get asked this question all the time, is there some theoretical perfect visualization? And the answer is no. And nobody who works on this will tell you that the answer is yes. It's not like physics. It's not a right answer. And so really the best way to do it is through examples. And so we just thought we would do it this way. And just one reassuring thing, I just came back last month. I was in Berlin at the IEEE visualization meeting, which is, the equivalent of the AAS for the visualization world. And I gave a talk in a new track that they have, which they call Viz in Practice. So they admitted, like, we're talking to each other, we're not talking to scientists. And so now they're inviting, so there was like the woman who did the amazing Kepler, not Kepler the satellite, but Kepler the visualization software from Twitter. I mean from Uber, sorry, they have a mapping program called Kepler, which is amazing. So she gave a talk, I gave a talk. So it's like people who are using this stuff in practice, and so hopefully it's supposed to feed into the visualization community so they realize there's a problem. So you're right, but this is the best you can do.
Well, I'm sorry. I'm hoping to have this so that if people like yourself, when you are in the right moment and if the timing and everything works, you could put your draft visualization in there. And if you could create a community, the others can comment too, right? So that would be a way to deal with that, because there's no real 10 commandments to follow, unfortunately. So it would have to be case by case and needs to be rethought and evaluated. And if you could create a community in which that, people can offer each other critique or help, that could be a good way to go about this, I think.
I was going to say, what would be really useful, what we do many times, is make a poster. And a poster is a completely different visualization problem, because people walk by and in 10 seconds you want to grab them and give them something. If you could put 10 things to remember when you make your poster, or colors to use, should it look like Tide, so we'll all buy
I
it.
did actually make a blog post once. You Google my name and how to make a poster. I think you
Oh, do you? Oh, okay. Well, did you link it here?
No, but I will. Thank
But you should.
But by the way, the answer to that
Yeah.
is the best poster I have ever seen in my life was João Alves' poster, and unfortunately he and I are giving a presentation. If you don't know, João Alves is another person who's really interested in astronomy and visualization, and he's here as a Radcliffe Fellow this year, and so he's around. So he's another person you can ask questions to. But he made the very best poster ever. He found a result, which actually turned out to be wrong, but it was really important at the time, okay? But it was this thing, and it basically was one graph. It was this big, the poster. The graph was this big, and the poster said, the core mass function is the same as the initial mass function times 3. And it was just this huge plot, and it was one sentence.
And that's good. That's all you need. Yeah.
And if you can do that, that's the best poster ever.
Yeah. Well, we always have little contests, poster contests at various meetings, where you have to go around and look at them. And most people just take their preprint, staple it up, 10 pages, and walk away. And a disaster.
They don't get the award.
But I think
No,
that's
no.
also, I mean, that one is also about who your audience is. So like, one of the posters that we made recently was for Glue, this software that I was talking about. Actually, can you go to the Glue website for a second? Sure. And that was a poster where all the PIs from all of a particular program at NSF were coming to a meeting.
Right.
And so instead of making a poster that was like one giant graph, that was like the perfect Joao poster, you actually want to, it's Glue Viz with, yeah, okay. Scroll down.
Missing one letter.
Keep going down. Yes, you have a poster. Click on that.
Okay.
Okay. So this is a way busier poster than anybody would ever make for a meeting where you want to catch people's attention. That's actually very big. Can you do explore more content there at the bottom?
Explore more content. Oh, there it is.
And then scroll down. And you'll see that it's this huge thing.
Oh, there's a lot of
So
stuff.
Keep going. Or maybe download the PDF so you can see the whole thing at once. But you see how it has these huge labels? Okay?
Oh, yeah.
And then each one of those, keep going, it goes over the bottom, would be, it's a huge poster, right? So, but anyway, each one of those would mean something. It's like, oh, I want to know about Jupyter Labs. Oh, I'll look at this. Oh, I want to know about user-defined images. So you can read these red labels from really far away. And so even though this is like way more information.
Was this
than
interactive, so you could click on that or something? And it would,
it is online, yeah. And at
Oh.
the top, there's an overview. Go all the way to the top. Okay, so that thing is an architecture diagram
Yeah.
of how glue works. And
Yeah.
if we were just trying to, like at a computer science meeting, that might be the whole poster.
Yeah,
Okay?
yeah.
But this is like, there's 150 PIs, and NSF wants you to collaborate with the other people. And so you put these things, it's like, hey, are you a Jupyter person? Look over
Right,
here.
yeah.
And then, you put all the online things at the top. But, so this is, the only reason I'm showing this is not because like, this is the world's greatest poster, but because it's a who's your audience thing, even with posters,
Yeah,
right? So
yeah.
this is other people making software, so you can put a lot of information because they're going to want to find
Sure,
it.
sure,
The
sure.
meeting with the giant graph is a bunch of people really tired of looking at 150
Well,
science
that's
posters.
what most AAS
Right.
meetings are, yeah.
Oh, double S means, yeah.
Yes, we should definitely link that poster thing.
Yeah.
3 of our PhD students got 3
Yeah, you should link it, yeah.
best poster awards in 3 different conferences.
Yeah.
So I think that we have also gotten good at this.
Yeah.
So happy to.
But you're so right that is like a hugely important
It's a need,
kind of
yeah.
format.
Yeah.
for-
But that's
for
what
astronomy.
we use a lot more than, our colloquia or something.
This is true. This is true. People tend to do a better job. I don't know if anybody else has noticed, but I think slides in colloquia have gotten better and better, and especially the last decade.
Yeah, oh yeah,
Have
well,
not gotten
PowerPoint.
equivalently better.
Yeah. But it used to be view graphs or slides that you had to make up months ahead of time in.
It's like
Still possible
yes,
on the plane.
less yellow on blue background now.
Would you say less yellow on a blue background?
That's right.
Oh, but there are some people who never want.
Some people still.
Although some
That's what
people
Bill
give
Gates
awesome
did.
talks. It's
We
still
s-
true that your content is the most important thing.
But Bill Gates, when he was introducing PowerPoint at a AAAS meeting in Seattle,
Did he
30 years ago, he used blue background yellow, and for years we all used that.
Yeah.
Bill
Oh,
Gates
it was
used
his
it.
Well, I will tell you that often the yellow text on
Yeah.
the background is highly readable.
Yeah.
More questions? Okay, great. Well, Peter had to leave, but again, Peter is now your connection, Peter Williams, to more stuff like this and more software, and of course, I'm happy to help too, but just remember Peter, and thank you all for coming.
Okay.
And thank you, Margie. Thank you.
I actually have to run to conference, so I'm on my phone.
Oh, you're gone here later.
Oh, okay, I'll start real quick. Sorry, when I talked to you yesterday, I was waiting, so basically, just and I were discussing.
Yeah, I don't really like the jiggle as much. Their work goes at least it's slightly
Anyways.
If it was slower, I think it looks great.
I think you just but yeah, that slowed down.
And so,
Looked really good.
you know, we got marks on.
I think we can make it good enough.
So I was like, well,
Honestly,
Oh, yeah,
And you have to march along in video. And
so I asked Glenn Langston
spend a
about
lot
that.
of
He's the
time
program
finding
officer
things
who's been
and
supporting us for
trying to
years.
time
And he said just keep them in the loop, so
exactly
we'll take a step and draft a press release and
So
run
it's
it
kind
by.
of almost.
And his only
Sometimes I
comment
just
was,
rearrange the words or get
I would appreciate it if all mention of NSF wasn't dropped from the press release, which tells
Yeah, I really like the idea of
the way
what's the
to
purpose.
prevent that is
Because I always
the program
ask,
officer
why are we
at
making
NSF
this
is
video?
quoted
What do you,
as saying how great the work is.
from there?
So he wants
And I
our
also,
press people to
also
call
tell
him, so he
people,
can tell them.
if you have a graph or a picture or an image, please talk about that, bring it. And sometimes I actually put it in a teleprompter so that when they're talking to the camera, they have this thing that they're
Oh, sure. Oh, yeah, I know.
They can say,
Yeah,
you can see the
yeah,
two
I know.
axes, you know,
Yeah.
and I always get them to say, on
First time
one
we've had a
axis you
video.
see this,
Yeah,
and the
yeah.
other axis you see that. So,
Because it looks so much better. I mean, the old ones were already pretty cool. I mean,
Yeah, yeah. Anyway, you would- So now what?
yeah, that's a nice word.
Well,
And actually, what
yeah,
I really love
so,
is blend, not with iteration 0, but with Waystar 17. Because that'll look horrible in comparison.
they're pretty technical, most of them.
for her too. Right, which
Okay. Well, thank you so much. Nice to meet you. Okay.
Yeah, it's wonderful. And the big bins weren't even used well, so they're still smeared out over.
Yeah, ours is great, yeah. So we should have explained, we should have put like subtitle, no
That's
astronomy.
what we promised. So this is a great way of showing video.
But yeah, so you can help us, especially with the display modes and
video
videos.
stuff.
Yeah, but I was just gonna say,
Some
yeah.
problematic ones too.
Yeah, so we'll loop in the Stanford.
And Andrea's thing about a poster is totally true, we should have a special
Because it's funny when you do things like this, all the different institutions kind of want to,
Yeah, so it's more like
they at least
what
want to know
is-
about it, so they
you know,
don't
it's
get
like I can
blindsided.
only send him
So it means we have to tell
emails.
Stanford and Berkeley and Penn
Like,
State
last time I
and
saw
Gaia,
him,
like just tell everyone
Just like,
we're doing
you're-
this,
you have a lot
and
more
then they'll
experience.
probably do
I don't
something.
know, like,
I've had people do this to me
In
a
my-
few times.
Yeah,
And then I'll
it's like,
I'll
when do
call
I
it
get
Dennis
Sort of
and provide
possible to get
her
stuff
plan
like
and
this, but
say,
sometimes it's just not possible.
we'll give you
It's terrible.
a day's
Yeah,
So I
lead
have like
time
one
if
paper
you
that's
give us a
behind my
favorable
desk.
position here.
Yeah, yeah,
And
yeah,
it shows you the 100-page draft.
yeah.
Yeah, and I published that. So that's.
Well, I should say,
that's not the
it's
answer
like,
you
I'm
wanna
not
hear,
asking
but-
him for any more work, it's just like, just send me your
Well, I
stuff.
asked and then I got the Excel spreadsheet.
Yeah, I actually should have started the footwork on this a week or two
Yeah.
ago.
So you also have to be careful with which.
I was
Yeah, I
aware
mean,
that
I
everyone
check
was aware
everything.
of things too.
Yeah,
Like
yeah,
nothing
yeah.
gets done
Can't,
this
for some
year.
reason you can't check it.
That was not a bad
No,
time to
this
start.
How hard is it to read?
But just getting it
I don't have the
out
time
of the way
with everything
before,
going
like,
on.
because leading up to Christmas.
And not even that, like, Christine was emailing us about it, like, oh, I
Yeah,
think she's
nothing
applying for
happens.
jobs.
I would say.
That's a terrible time to try to do press release.
Yeah, but
So it'd great,
I
be great if
go to
we
high
could do it
school
in
in
like 2
Austin.
weeks. Anyway.
I was wondering, I told Stella about it, she's like,
Because
oh,
even
I'm
just-
not gonna start,
I
I'm
don't
like,
think
that
we'll be
seems
able to
so
tell the difference
unprofessional.
between
No, it
version
works.
4 and the video.
It would have, but it's like, how do I know where you're at? I don't know.
So, but you know what high school is?
No, I
So Greg
don't.
should just make some beautiful videos and we'll get them on the
No, I
web.
don't.
So
Put them on
finally.
YouTube so that when a million people want to look at them, we don't crash our server.
Say, I know you must be so busy with
Right, you
your job
should
and
use
your
YouTube for
family.
that. And what's cool on YouTube is it's counting views. Like when we posted the Fermi bubbles there, and it's like, this has been viewed 1.7 million times. You know, then it's like,
Of,
Okay,
you could tell his.
okay.
Okay.
Yeah, no.
But if the email is.
because I think people will like
At
this.
that school, that'll be like that.
It's such an impressive video.
Okay.
Anyhow, so, and then, of course, in a year or two, at whatever
Yeah, no,
we'll have the British version, so it'll be
Okay.
By the way, so is
Like-
there a copy.
also maps of stolen properties.
Meredith needs
Stars are gonna be embedded in the.
Like it'll be the real stars.
Yeah, and like
not a-
her email was reassuring because she was saying like when she was a master student, she had
entire
problems.
If you want to do
plan.
basically
As long as
learn how to
decaps.
slightly more efficient venue.
And I
Okay,
have,
yeah.
so that's what I've been doing.
Yeah, but I feel like texting is
Find out
kind of
the name
like
of the, does this person have a unique name?
I now have.
I don't know.
What's his name?
Evan Carter.
That's terrible. For the
Yeah.
internet. But if you try Evan Carter, Oscar,
So now all of the RVs, and we're
It might be so new, it might not even be updated. He just started like a month or two ago.
perfect, 'cause I know you just.
Yeah.
Empowering students, and by the way, I'll do all the work for you. Just-
Okay.
Oh, I told him that. Yeah. Yeah, I don't even know if he was trying to say. I'm also just concerned too, because I know he has some
Okay, yeah, I want to see all that.
masters and stuff. Like, he finished, but he almost did all that dissertation because he was so stressed out with the writing. You know? So I'm just, I don't
Well, I
know.
think you could make it positive. You could say, maybe you're different, but in the message you could say, I know it'd be so cool if your high school students knew that you had these published papers and I'm willing to do all this for you, just so you say.
Yeah. Oh, yeah, exactly. That's the question. I don't know.
But I haven't typed it, I set it up on holy
Kept
sync,
trying to
so
get her
it's actually
to drop on
going.
Yeah.
Yeah.
Well, we have a Dropbox folder. Yeah.
So bad about that.
He did his own thing. He only like
It's got 36 cars.
Right, so that's
And
the
the
fashion
fashion.
Yeah.
Yeah.
I got two
I want all your
18 core
stuff.
processors. Yep.
So I have it set up so I do all the like for all the work.
I didn't know he was gonna get out of it. I just thought he was like busy with his masters. I didn't want to like impose too much, but at the same time, I'm like, if you want to stay in astronomy, like getting this paper out where everything is done, like that's only.
Okay, awesome.
Nice talk. Thank you. Let's try to do you have a card? I can email you later. We said at a time.
Okay, nice.
Yeah, nice.
to see you.
I did. I've been away so
Yeah,
long.
yeah.
I've hardly gone
I
to
don't know
any
when you're
talks
here,
this
then
year.
I
It's
come next
terrible.
time, you might not
But I'm
be
probably
here.
going to 3
I might be here
different
for
sure.
But yeah, no, definitely. I would love to visit you in
For
Zurich.
physics,
I've never been to Zurich.
gravitational lensing stuff.
Yeah, it'd be good. Oh yeah, I just followed you on.
I know, I saw that. I was like,
It
that
would
would
be
be
good
fun
to,
too.
yeah, I can show
Exit out
you,
an
maybe we can
absolute
chat tomorrow, or like with Catherine, we can show you like our
I don't know.
yeah, we can do Friday.
Alright,
Cool.
because I didn't want it actually.
Great,
And not that
thanks.
it's gonna be terrible, that's not meant for.
Not really meant for us, yeah.
Yeah.
I want to introduce you to Zoya.
You look familiar. Have I never met?
I've worked with Michelle.
Oh, that's right. Hi again. Then. Hi,
I'm a
hi.
fan of the Thank You with Web Design, and I
Ooh.
thought
Very
that
nice.
you love to hear.
Oh, well, thank you very much.
She said that already in the email. That's so nicely put together, and I forgot to tell you. And now she's like, "Who designed this?" Like her.
Anyway, thank you.
What's the process right now for people to submit visualizations?
There is a thing on it, on the lower left corner that says, what is the process to submit stuff? Click there. And honestly, I don't remember exactly what we said, so that's
But
why.
it's mostly like, it's still it's still a lot of effort on you to like.
It is, but do you want to help? Because we're desperately looking for someone to help.
Me personally, I don't know if I have the cycles, but the reason I ask is because we have like 8 channels
Well, I mean, it was
on his.
That'd be great.
There's a whole.
That would be fantastic. So where are you now?
I just switched to Adobe. I was at MIT. I'm at Adobe right now.
Oh, okay. Adobe in which location?
The location, the one that's close to MIT, but really I'm at MIT.
Oh, okay, okay.
They have a tiny office here.
Oh, cool. Well, no, that would be excellent. And like people like Martin Wattenberg and Fernando Villegas, they want to help too, but nobody has any time. We need some people with time.
Well, the time is usually
that's the
Right, but seriously, like if you know a student or two at MIT, Arzu and I have been talking about this, and we can probably get money, but we have to have a sort of plausibility argument before we can get money.
I think it's exactly what it was before. It's just.
I've actually been poaching students from Harvard, from MIT.
Yeah, students getting closer and further and closer and further.
Not from
Just go in a
Husky,
circle.
but from the data center.
Yeah, from Pavlos and everybody else's world, yeah.
So Pavlos knows me well.
Okay.
Yeah,
So did he tell you I
it's going in a
hired
circle
Pavlos
like
and
this.
Husky? Yeah, I did.
And it's going
I'm
through
Michelle.
times as fast.
It's all in.
Yeah, that's
It's terrible. But, well, it's great. It's not,
I think you're right.
and I met Arzu through Michelle.
Yes, and I tackled Zoya and dropped her an email because I knew her from her work.
Well, the tour of the galaxy is obviously.
Well, actually, what I was going to say is I was going to offer
I
to
think
take you
that was
to an
meant to
early
be
lunch
as close as
because I have to go to Radcliffe to
to
get
the
ready for
actual,
this other thing.
I'll
It's
show
your
it out
kids.
times
I was going to invite you if you
Oh,
wanted to
you're
come.
gonna.
That's great.
I have an infant to
Oh, go do that. Go do that. Go do that.
Another person's lunch.
And you,
But it was nice.
we're going to go out for a little while. You want to come?
We will be in touch.
Snacky, kind of lunchy snack
Oh,
early
it is
thing?
kind of lunchtime.
Almost,
I'll
yeah.
have a snack.
Unfortunately, I have to go to Radcliffe like shortly, like in an hour. And so if we
You want a
go,
quick snack here?
right, if we go to like High Rise or Sarah's or something, it'll be fine. You want,
Okay.
you want something?
No, that's great. If we go to High Rise,
Yeah,
I'll actually get lunch. But,
Sure, yeah. High Rise will be Arzu's favorite because it's got the most caffeine. Arzu, have you
right.
officially met Doug?
Yeah, I'm Doug Finkbeiner.
I don't think that we did. Hi.
Good to meet you.
Doug is Catherine's other advisor and my old friend and a fan of gigantic data sets and sort of visualization.
Well, everybody who
Sort
does
of.
gigantic data sets have to like visualization.
Although you thought that Greg's beautiful, realistic reddening
On my
video
phone, it looks
like
brown and white. It did. Look at it on the phone.
Oh, I showed him.
Did you see it on the phone what it looks like? You look at it on the phone?
But
Yeah.
like he tried as hard as possible to make it realistic. Like that's what the dust would actually look
I
like.
know. And then I wrote to him again and said I liked it. Did you not
I
get that
didn't
email?
get that. Kind of like
Maybe I
I
didn't.
You CC'd
Maybe
me on
CC
it.
everybody.
I mean, I kind of like the glowing dust. Like I was in favor last time we did this. Of,
We should
dust
show
glowing.
Arzu these two. Hang
Yeah.
on. So no, I
Yeah,
wrote back
see
to
what she
him
thinks.
yesterday after I looked at it on my laptop and said, you know what, I was totally wrong. I really like it.
Oh, okay.
Boring, good luck, Mo.
Hang on. What'd you say?
Because I think your first
Biological
email
things.
basically said it looks like shit. Is how I interpreted
Biological-
it.
Yes,
I
it did.
Biological thoughts.
That is what that's exactly what I was meant to say.
If we're going across the street, I should grab my jacket.
Okay, why don't you go get your jacket? We'll wait a minute.
Although I guess if
Wait,
we
here,
walk
see,
fast,
I wrote, Greg, glad to
Hi,
hear
Rose.
it looks better on a laptop. Yes, please show the video to Joao. Okay.
Okay,
So, but if you look at it, Joao, Arzu, you got to see this. Hang on. Wait, so I wrote nice movie. And I also think, okay,
So
here.
we've been making 3D dust maps. This is much better than what we did in the past. So this is orbiting the sun at 50 parsecs.
All right, so now it's got a little bit of color. I must have been very tired. But I was worried about this brown, and I thought like, oh, that looks kind of biological and gross.
Dust reddening.
But
Think of coffee, spilled coffee.
I don't know, but it
Because you felt something
it
else.
looks much better when you can see the kind of color gradients in the background better.
We need to slow it down a factor or two. So it's blurring between two versions of this
That's on
one with better
purpose, yeah.
regularization. So that, okay, now it's the sharp version.
Yeah,
And then
and
it'll become the blurry version again.
yeah, so why was that was just to show the difference?
Yeah, we're just testing how much our regularization is helping.
Okay, so this isn't like.
So we
Helping
wouldn't
a
show
lot.
that to the public.
All right,
We would
yeah.
just-
But no, don't worry. I wrote back to him and said, actually, I think it's great.
So this is all derived from colors of stars, between colors of a billion stars.
But I swear to
and
you,
they
when I
make
looked
that.
at it in a stupor on my phone in the dark, and my phone must have been because it automatically changes to the
Yeah.
light, all I saw was brown and white.
So we'll do the tour of the galaxy video and all the other stuff like before, but I think this is press release
By the
quality
way,
at
don't
this
we
point.
think that it is? And don't we think that her proposal, like we haven't been in the same place since then, is like amazing?
Yes, it is amazing. And doing a press release on this
I'm
might help
hoping
us
that
get it,
helps
too.
because I think Glenn Langston will like seeing the press releases. Maybe he'll want to make one.
Except we have to be very careful to, in the press release, you have to say, and we can do even better and
Yes.
even more, because
Yeah.
otherwise your fear about,
Oh,
we gave them
exactly.
the money and they're done, is going to come true.
Right, no, there's
Because
a
you're
lot
looking
more to
at
do.
you're really only looking within a few hundred parsecs.
I was
Really,
like, this is just.
at high latitudes. Like that's what those videos are of.
Catherine's proposal is let's do that for the whole galaxy and let's connect it to the velocity of gas while we're at
And
it
the
and figure
stars.
out like.
And yeah, and
We'll
for
have
everything
stars
about billions
in-
of stars.
But like having the stars in there would be so cool.
I love how the 5 billion stars is like an offshoot.
Yeah, right. We just,
Like, by the
as an
way-
aside, we'll do 5
So
billion
we'll wait
stars.
for you for 2 minutes. Actually, I heard one of the ladies will come right.
Actually, no, you're short of time. Let's do
You're gonna
this.
just go with a sweater?
Go,
Behind us there.
Okay, where's my coat? You want my coat? It's not that cold.
it's not that cold.
No, and I'll buy you lunch.
50, 45, 50.
Okay, in that case, bathroom, I'll be right back.
We can't just leave it here, actually.
I'm gonna take these. I'm gonna take these to so I can use them tomorrow.
Hey, Doug, wait.
I'm gonna consolidate these.
I guess he decided to go get his coat.
And put these in the grab lab.
Keep one? Arzu, did you get a donut?
I should try one.
I think people really liked your talk.
I like
I
it.
hope so, thank you, yeah.
My question is, how do you actually measure people's confidence?
Yeah, there's different ways. Sometimes we ask them direct questions and give them Likert scale and say how, like they give the answer and then we say how sure are you on the scale of 1 to 5 or whatever. And sometimes we infer them from the question itself, like
There's that one, because I turned it inside out. The inside is dry.
sometimes it's like embedded in the question. When somebody says clearly a valley instead of a valley, then we say, okay, this person is more sure than the other one.
Okay.
So you did go get the coat?
Yeah, I just ran the bathroom.
Oh.
Yeah, you should not bring these things. These are terrible.
I'm very proud of myself. I'm going to stick with you. I'm not
Awful
eating any of them. They're awful? Thank you.
No, they're awful.
Where did we put my bag?
I'm gonna stick these in the grab lab on our way, just right there, if that's okay.
Yeah, can I carry something for you?
I'm taking this with me for tomorrow because I have a.
I can have something here.
Can you something for me? Yeah, we'll take. Yeah, let me just put this back.
Yeah, Doug, tomorrow is another day of talks, right?
We have solid talks constantly.
Wow, is it waiting for me to do something with this other thing? So, what are we doing with this? We're just leaving it?
I'm not sure, yeah. What do you normally do?
I don't know. So wait, what is?
I'm gonna stick these in the ground.
Are you gonna take the coffee table?
Yeah, I'm gonna stick them right
Okay.
the door. That's okay.
Yeah. Why don't, hey, Arzu, can you guys walk the high rise? Give this to me.
Okay, we can get started at high
Get
rise.
started at high rise. We'll be right there.
Oh, we can just call this. Yeah. We've got. Why was it going through the door?
Should I follow him? Yes, follow Doug.